Hello, my name is Stephen Gottlieb and I made up the West video. At this point I would just love for you to sit back and view a sample demonstration. That way you get to see a little bit of my teaching style. We were given this matrix equation. This matrix times xy is equal to 6, 8. And we're told what the inverse of this matrix is. The inverse of this matrix is this matrix. And again, we want to solve for xy. What can you multiply this matrix by to get 6, 8? Well, let's talk about the theory, what's going on. You have A times xy is equal to, let's call it B. Now, matrix multiplication has associative law. Somehow, we want to kill off the A. So, if I take this left equation, and on the left-hand side, I multiply by the inverse of A. Of course, on the other side, I also have to take the other side, namely B. I'm multiplying the left by A inverse. Now, matrix multiplication has associative law, and we are multiplying three matrices. As long as I keep the same order of these three matrices, I can move the brackets around. The right-hand side is just A inverse times B. Now, a matrix times the inverse, regardless of which side the inverse is on, is identity. The inverse of A times A is the identity matrix times xy. And we're not going to do anything to the right-hand side. Now, there's one nice thing about the identity matrix. In real numbers multiplication, the identity is 1. That is 1 times anything is the anything. In matrix theory, identity times xy, or the identity times anything, is just the anything. So xy is A inverse times B. And this is what we're going to do to find xy. To find xy, you take the inverse of this. That is this matrix. And you multiply it by B, that matrix. So now we can write down the answer. Little xy is nothing more than the inverse of this matrix, which is that matrix, 4, -3, -5, 4, times what we are calling B. A inverse times B. But B is 6, 8. So now we know what B is. It's 6, 8. And once we multiply those two matrices, we are done. Yes, 6, 8 is a matrix. So we multiply by 6, 8, and we'll be done. The whole problem now is to know how to multiply matrices. Multiplication of matrices, in my opinion, is very similar to the distributive law. Instead of distributing something to each term, we are going to multiply each row by each column. Rows from the first matrix times columns in the second matrix. Multiply each row in the first matrix by each row column, multiply each row in the first matrix, multiply each of these rows by each column in the second matrix. We get a little break here. There is only one column in the second matrix. So let's do this work on the side and we'll be done. I take the first row. Personally, I like to write it that way. And I multiply it by the first column. You get 24. You get -24. If you happen to add these numbers, which you should do, you get 0. Okay, so where does this 0 go? The answer is kind of natural. It's a natural answer. First row by first column, that's just where I'm going to put it. In the first row, the first column. Right there. Now we do this all over again with the second row. I write down the second row. I like to write it down vertically. And I write down the first column. And you multiply. You get negative 30, you get 32, and you add. And when you add, you get 2. Where does the 2 go? Well, let's see. Slow it down. Take your time. Second row, first column. That's the answer. I'm going to put it in the second row, first column. And of course, if this matrix had another column, if it did, I would multiply the first row by the second column. And that's just where I would put it. First row, but this time second column. Then I would multiply the second row by the second column. And it would go to the right of the 2. Okay, so we finished the problem. We have our answer. XY is 0, 2. Well, exactly what does that mean? Oh, their first entries have to be equal, and so does the second entries. That is x equals 0 and y equals 2. Now let's check this. Maybe we made a silly error. We claim that when we take matrix, the matrix 4, 3, 5, 4, and we multiply it by 0, 2, that we are going to get 6, 8. But maybe we made a mistake, so let's check it. So first row times the first column, 0, 2. You get 0, you get 6. When you add them, you get 6. Okay, so far it looks right. I got the 6. Now I'm going to take the second row, 5, 4. Take the second row, 5, 4. And I dot it with 0, 2. 0, 2. You get 0, you get 8. If you happen to add these numbers, you get 8. Second row, first column. So I'm going to put it. Second row, first column, 6, 8. And you say, yep, that's what I wanted, and that is what I got. This completes the sample demonstration for the West exam video. I hope you enjoyed it, learned a little bit about solving linear equations using matrices. Most of all, I wish you great success on your upcoming exam. And thank you for viewing my video.